Alright, we can calculate correlation coefficients all day between sets of numbers. The trouble is we'll never know if those numbers, those values are statistically significant or meaningful. Alright, so what we're going to do now is a t-test on the slope. Sorry, a t-test on the correlation. This will be a lot simpler than the t-test we've done up to this point, in the sense that it's always a two-tailed test. And it's always the same hypotheses. So null hypothesis is that the true correlation, in other words, the population correlation, is equal to 0. Alright, in other words, there is no correlation in reality. And then alternatively, that the population correlation is not 0, and that you have some correlation between your two variables. Okay, so in our t-tests, the strength or the test, the significance of the correlation, those will always be the hypotheses. The next step, clearly for any t-test, is the degrees of freedom. In simple regression and in correlation, the degrees of freedom is n minus 2. We have 7 data points, 2 degrees of freedom. So 7 data points minus, we lose 2 degrees of freedom. We're left with 5 degrees of freedom. Right? We lose 2 because we need 2 points to draw a straight line. Everything else is extra. We'll use the standard alpha of 5%, and so with the two-tailed test we'll need t with 5 degrees of freedom and 2.5% in the tail, and that result coming from the table, 5 and 2.5%, 2.571. Alright, from there we can do a decision rule. And just like the hypotheses always be the same, the decision rules will be the same except for the critical values. So if t-calc is close to 0 or is between the critical values of plus and minus 2.571, we'll skip the do not reject part that we've used before. We'll say there is an insignificant correlation between our two variables, and we'll spell those variables out. The annual growth rate, and the return on equity. Right, insignificant means too close to 0. There could be no relationship, but given the data that we have at hand, we can't tell. Alternatively, t-calc is not between our critical values of plus and minus 2.571, in other words, around the tails. Again, we'll skip the reject the null and accept the alternate part. We'll say there is a significant correlation between our two variables. The growth rate return on equity. Alright, we're ready now to do calculations. T-calc is very simple in comparison to the alternative, which is the calculations for the t-test on the slope, which we'll see later. But anyway, the t-calc for the correlation is little r, coefficient of correlation, divided by the square root of 1 minus little r squared divided by the n minus 2 degrees of freedom. Alright, so in our case, little r was 0.73. Divide that by the square root of 1 minus the 0.73 squared divided by the 7 minus 2 degrees of freedom, and put that in your calculator, and the result is 2.388. Okay, we don't have a diagram, but you can imagine that the positive 2.388 is between the plus and minus 2.571. So our decision is that there is an insignificant correlation here. Alright, everything sounds good, but it's not good. So since t-calc is 2.388, and since that is between the plus and minus 2.571, there is an insignificant correlation between our two variables. Growth rate and the return on equity. And remember that the R does not distinguish between, in a sense, what the X and which is the X and which is the Y variable. You can turn them around and the result will still be the same. Alright, it's only up to us to figure out, in a regression sense, which is the Y and which is the X. Anyway, this is a t-test on the correlation, so don't ever assume that any old correlation that you've measured or has been presented to you is significant. Alright, this one's insignificant, which means that we cannot use the relationship that we measured before to predict or explain, given this data.